All right, guys, we are on to law of cosines. So the law of sines, if you will recall, worked when we had two angles and a side, two angles and a side, or that mysterious two sides and an angle, okay? But the law of cosines is going to work when we have two sides with an angle in between, or if we know all three sides. Again, make sure your calculator is in degrees, not radians today. So go to mode, make sure it says degrees here. All right. So again, the law of cosines is used to solve an oblique, meaning a non-right triangle. It also works in right triangles, but SOHCAHTOA is easier and shorter than the law of cosines. But it will work when you have two cases. The first is when you know, this is actually what I would consider the first, when you know two sides and an angle in between. Okay, so you're going to put the two sides in here and here for B and C, and then the angle in for A. So I usually think of this one, I don't know why, but I usually say to myself, A squared plus C squared minus 2AC times the cosine of B. This is all multiplied together, and that's very important that you understand. And you can just type it in all at once, but then remember at the end it's B squared, so you're going to have to square root all that mess at the end to find B. All right, and then for side, 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 we have to work all this backwards to find an angle, and we'll get to an example of that. All right, it says, notice that the angle referenced in each of these is the one opposite the side you're looking for, okay? So this is just from your notes that you have. So on this, we have, we're looking for side B over here first, because we have two sides and an angle in between. So we have a side, angle, side situation, a side of 8 and 10 and an angle of 100 in between. So the first thing you would do would be to solve for B. So you would say B squared equals, and then the two sides are 8 and 10, and it doesn't matter what order you put them in, and then it's 2 that came with the formula, and then times 8 times 10 times the cosine of the 100 degrees. Okay? So I'll show you how to type that in, and I always type it in all at once. 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 100. You can do it in pieces, but the problem is students will sometimes hit enter here before they hit cosine, and that's not right because all of this has to be multiplied together. All right, so then I got, I hope it was B. Yes, B squared is 191.8, and then we need to square root that. See, I'll practice what you guys probably do. You go up arrow, enter. So 13.8, 191.8, and then we square rooted. And our final answer was 13.8. So we found this side to be 13.8. Now, they asked us to solve the whole triangle, and I'll go ahead and do that once, but I am not going to ask you to do that. Beyond this, what you would need to do to find the rest of the missing pieces is to find angle A and angle C. So you would then more easily move over and do law of sines. So the sine of angle A is across from a side that's 10, when the sine of 100 is across from a side that's 13.8. Type that real fast. 10 sine of 100 divided by 13.8. And that is the sine of an angle, so we need to do second sine of that number. So we wound up with the sine of A was 0.714, so inverse sine came out to be 45.5 degrees, and that's angle A. Now, we did inverse sine, so we're really supposed to also do 180 minus that answer, and look and get, 134.5. But if we already have a 100-degree angle, can we have anything bigger than 100? Nope. So we know angle A has to be 45.5, which leaves angle C to be 180 minus the 100 we already know, minus the 45.5 we just found, which I'm thinking is like, yeah. If I wasn't making a video, I could. I wasn't in the middle of a video. I know, I work all hours of the day. So I get angle C is 34.5. So we found all the missing pieces. All right. Again, it reminds you, okay, well, you can have only one obtuse angle. Make sure the largest angle winds up across from the longest side, etc. When you solve a triangle, which we're not going to do much of, it is best to always find the measure of the largest angle first by law of sines, or cosines, law of cosines. Find the largest angle first. But if you're not solving, if you're looking for all of them, then it doesn't matter. But if you find the largest one first, then you'll never have to worry about more than one answer to law of sines, is what they're trying to tell you. All right, oh, this says solve. Yeah, solve again. But it says solve, you should find the largest angle first. That would be angle C right here. So the side opposite squared is equal to the two adjacent sides added together minus 2 times the two adjacent sides times the cosine of C. All right, this is how I usually teach it. Every year I teach students to do it this way to fill in that formula. I'm going to show you this year because of COVID and the fact that we're not seeing each other. There is a formula that anybody could always use that shortens this up just a little bit, but I'm going to show you the way to do it algebraically. These were both added, so we need to subtract them both over to the other side. What's left over here is all multiplied together, okay? So we have a negative 2 times 20 times 12 times the cosine of C. This is all multiplied together. So to get rid of that, we're going to divide by it. And no matter how many times I tell this, somebody's going to think they can just type all of this in and then move it over to the other side. But you can't, guys. This is multiplied here, so you have to divide by that piece. So this is what we need to type in, and that's going to be the cosine of C. And then we're going to need to do inverse cosine. So I guess I should do it on here for this, at least this one. We have 28 squared, whoops, see I can't even type that, 28 squared minus 20 squared, also minus the 12 squared. And we're going to divide that. I'm going to go ahead and hit enter. You could do the bottom separate. Maybe I will do that separate. Negative 2 times 20 times 12. I think I know what this is going to turn out to be. So the cosine is 240 over 480 over negative 480. So we're going to do inverse cosine of 240 over negative 480. Well, that's a half, guys. Do you remember where the cosine is negative 1/2 on your unit circle? It's in quadrant 2. I think we're going to get 120 here. There we go. All right, now that we found angle C is 120 degrees, we know that nothing else in this triangle can be an obtuse angle. So they want us to find the other two angles. We only need to do law of sines once. 120 is across from a side of 28. In the same way, we'll say the sine of 12 is across from B. Sorry, I just did what I don't want you to ever do. 12 is a side, not an angle. Here we go, the sine of B is across from 12. So you get the sine of B is, and we get a decimal, 12 times the sine of 120 divided by 28 is 0.37115. And then when I do inverse sine of that, I get 21.8. And then if I know that B is 21.8 degrees, then to find angle A, all I have to do is subtract 180 minus 120 and 21.8, which is 38.2. Ugh, I hate these solve for all ones. I won't give you, oh, is there a whole nother one? Oh, good, that's the only one we have to do. Phew. So this is an application problem. I'm going to pretend for a minute that the picture isn't drawn right there for you. It says during an orienteering exercise, two hikers start at point A and head 30 degrees west of south. So instead of heading straight south, they're going to head 30 degrees off towards the west of south, to point B. They left A. They hike 6 miles from A to B. And then they hike to point C, which we don't know where point C is, but it says it is directly, and they go back to point A, which is directly north, and that was 8 miles. All right, so this is the picture, which they've already drawn us over here, and we need to find B to C. So we have two sides and an angle in between, so we're just going to go 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 30, and that's going to give us x squared, so we got to remember at the end to do the square root. 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 30. Don't hit enter along the way. And I got 16.86. When I square root that, I get 4.1 miles. All right. This is again finding an angle, so I do want to do another example of that for you. To find angle B, it is across from 10, so you go 10 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 times the cosine of B. So Hofbauer says we should do 10 squared. These were both added, so we're going to subtract them over to the other side. Those are all multiplied, so we need to divide them over to the other side. So that all divides off. Now, there is another way to do that. It says here to find angle B, you can use this formula. Does anybody see what they did? When they took this and subtracted and divided it by negative 2ac, what they did is they took this negative and they distributed it up here. So that would change all the signs. So that's where they got a positive a squared and c squared and a negative b squared. And then it's all over 2ac. You can use that formula, it's fine. just going to have to write it down somewhere, okay? And make sure you follow it carefully. I'm just going to stick with doing it this way. So I'm going to type the top in, 10 squared minus 5 squared minus 7 squared, and get 26. Type the bottom in and I get negative 70, and this is the cosine of b. So if I do inverse cosine of 26 over negative 70, or whatever decimal that gives me, should be, because it was negative, it's going to turn out to be an obtuse angle. I got 111.8 degrees, and I'm going to check my notes. That's what I got. Okay. This is finding this side over here. So I think I'm going to let you guys do this one. You would just have EF equals 40 squared plus 49 squared minus 2 times 40 times 49 times a cosine of 53. You can check, but in my notes I have that this came out 51. I'm going to go on and do these problems. These say just set them up. You don't have to solve them. I just wanted you to think about, is it law of sines or cosines? We have two angles, which means we can find the third if we need it. Mm, 180 minus 108 and 38 leaves 34 up here. Now we're trying to find QR, which would be this side here, it says. So because we know things that are across from each other, it's always easiest to use the law of sines. So the sine of 34 is across from 20. In the same way, the sine of 38 degrees is across from x. All right, not going to solve. Number 7 says find angle A. Well, if we don't know any angles, we cannot use law of sines, okay? You could go to the notes up above, and it said the cosine of angle A equals, and you could use this formula, b squared plus c squared minus a squared over 2bc, okay? Or Hofbauer says if you're finding A, 18 is the one across, 30 and 17 are the ones next to you, minus 2 times 30 times 17 times the cosine of A. So you would subtract the 30 and the 17. These are all multiplied together. So then we're going to divide all that by negative 2 times 30 times 17. I'm just curious because we've had a lot that came out negative. I think this one's going to come out positive. If we do 18 squared minus 30 squared minus 17 squared, we get a negative on the top. And on the bottom, if we do negative 2 times 30 times 17, we get a negative on the bottom. So when you do inverse cosine, it's going to be an acute angle because these are going to cancel each other out and become positive. So second cosine of 865 over 1020, I got a 32-degree angle. You didn't have to finish that one. I was just trying to show you one where it came out acute. Seems like we had a couple that were obtuse. Are we done? I didn't think so. Okay. Find angle A. This is a situation where you can use law of sines, but you are finding an angle, so you have to be real careful that there's not two possibilities when you do inverse sine. But if you already have 100, there's never going to be another obtuse angle, so there's only one possibility. Remember, you'd have to do inverse sine at the end of that. All right, this one says find DF. So this would be law of cosines. And don't forget to square root at the end. And that brings us to our last one. This one says watch out, because I have a feeling there's two possibilities here. If we have angle A is 53 degrees and across from that is a side that's 28 feet, and somewhere is a side C that's 29 feet, we're supposed to find angle B, which would be here, but unfortunately we're going to have to find angle C first by law of sines. So we'd have the sine of C is across from 29 in the same way that the sine of 53 is across from 28. So 29 times the sine of 53 divided by 28 is 0.827. And then when we go to do inverse sine of 0.827, there are two angles that have that same value. One is acute, inverse sine 0.827. I got 55.8. I used the whole angle, the whole decimal. But remember, we're supposed to also do 180 minus 55.8 and see if that's possible. And I got 124.2. Now we have to decide if we can throw that away. Can this angle be 124.2? Well, it's across from a longer side, so it's possible. And 124.2 and 53 doesn't add up to more than 180. So angle A is definitely 53, no matter what. Angle C could be 55.8 or 124.2, which makes angle B, if these two are true, we have 180 minus 55 and 53 and 55.8, which would leave 71.2 to be angle B. If we had a 180 minus 53 and 124.2, that would leave angle B to be 2.8 degrees. Now, every year I have students who decide, oh, that's too tiny, I'm going to throw it out. But it's not, okay? It is possible, and that's all that it asks. What is it possible that angle B could be? Be a really funny looking triangle, but it's possible. All right, that's law of cosines.